Hello everyone, welcome to the first video lecture on science communication. This is Dr. Netram Kaurav. We at the Department of Physics and Electronics intended to provide a comprehensive learning management system for teachers and students, as well as virtual labs where students and teachers can access various learning tools such as additional views resources, video lectures, animated demonstrations, and self-evaluation. So let us begin with. You can see virtual labs is a worldwide phenomenon. We also have a virtual lab from the Ministry of Education wherein you can find the various disciplines of virtual labs, for example electronics and communication, chemical engineering, physical sciences, chemical sciences. So let us see one of them, that is physical sciences. So you can find various virtual labs available on the website of the Ministry of Education. So for example we have IIT Kanpur, Amrita University, and many more. So if you see any of them, for example one of them is this Amrita University. Here you can find the various experiment available for the access of students and teachers remotely. They can learn with the self-evaluation, simulator, assignment, references, and then feedback. So these are the few components available in all these virtual labs. So similarly, at our LMS system, we also try to develop all these components in the virtual lab. Similarly, in our own virtual lab, first you need to go on the home page of the LMS, that is lms.holka.org, and then you will find a virtual lab tab on the right side. If you click on that, you will find a virtual lab. As of now, there is only one experiment, and in the coming days there will be many more experiments in this tab. So the first component of virtual lab is e-text, then video visuals, then there will be animation simulation depending upon the experiment, then the exercise for doing yourself. After that you will find the learn more various references. Therein you will find the literature of that particular experiment, and then at the end self-evaluation. There will be about 10 to 20 objective types multiple choice questions, so you can test yourself while answering all these experiments. And at the end there will be a feedback system also that yet to be uh, installed here. Now in the first experiment we need to index a cubic crystal X-ray diffraction pattern by mathematical method. So this particular method is applicable for only cubic crystal structures such as simple cubic crystal, face-centered or wave-centered. Here in the e-text we have provided theory and the process, some sample data for FCC and SCC. So if you click on the e-text on the theory, you will find the complete procedure how to do with this experiment. Here you will find all the details, procedure, methodology to get insight into the indexing of cubic crystal structure by the mathematical methods. Here I have also provided some standard data. For example, this is for nickel, and JCPDS card number is also there, so you can get it on the internet also. It has the FCC crystal structure, and you will find here we have two theta values. So depending upon these two theta values, we can calculate the corresponding HKL values, and then the pattern of those HKL we can identify the crystal structure of any unknown crystal for cubic crystal only. Okay, so in the first step, user defined data and some standard data is also there. User defined data, user can put their own data, or if you click on the standard data, then that standard data will be automatically filled in this field. and then we have various steps. In these steps you will find that how we can identify the crystal structure of any unknown cubic crystal. So here is the complete procedure. So you can see, first we will find 2 theta, then sin square theta, and then we will multiply by some integers 1 2 3 4 and so on, and always try to get that we should get some integer on the output column. So this process will be continue till we achieve some integers or the complete integers. So based on that integers we assign them HKL values, and by assigning those HKL values we can easily identify the crystal structure and then eventually the lattice parameter of unknown crystal structure. In the second tab we have videos for the experimental procedures. In these two videos we have provided how we will do experiment on the X-ray diffraction system. First, in the first video we have shown how you need to prepare your sample to mount it on the in the X-ray diffraction machine, and in the second video you will find how these peaks appears. So you can see, after mounting the sample we need to start the software which operates this machine. Here we have used the prototype ProtoMake system, X-ray diffraction system, and in the second video we have shown how this data is collected with the help of software and how the evaluation or how these peaks are appears in the data. So as and when there will be a fulfillment of diffraction condition, that is 2d sin theta equals to n lambda, you will find a peak at that particular theta value. So these are the two videos wherein you can get how the experiment is used to perform on any of the system, and then we will have animation. Okay, so you can see depending upon the 2 theta value you will have various peaks in the diffraction patterns. These maxima appears only when the condition of diffraction is fulfilled. So by the help of this small animation we can get insight into this X-ray diffraction pattern. Now moving on the do yourself. In this tab the actual exercise has to be performed by the user. Here the user can put their own X-ray diffraction data. After getting the X-ray diffraction data they will have a 2 theta value, so they can put here, or otherwise they can also use the some standard data which I have already put it here. If you click on the FCC, all the FCC data will be available over here. So and then we need to select a particular wavelength that was used in the during the X-ray experiment. So here you have two options and the other option is also there. Then you need to put your name and then email ID so that we can generate the certificate at the end. Here we have provided 8 options to fill the data. You can delete or get more by clicking on the plus sign in the interface. So after filling in that you need to submit, and then the second step will be started. So for the training purpose let us use FCC data. If you click here, it will automatically fill it. These 8 options can be increased and then we need to submit it. After submitting it, the second step will be performed by this software itself, wherein it will calculate the value of sin square 2 theta. And then as per the procedure, it will multiply it by some integer and divided by the theta minimum value. You can see this detail in the text. After performing this step, we need to see whether in the column we have an integer or not, or it is approaching towards the integer. So if you reach on the integer, then click on the final value, otherwise you need to click on the calculate on the more value. So it will do calculation for the multiplying 2. Again you will find that it is not reached yet to integers. There are some values, they are still away from the complete integer value. So calculate more options will be used. So this procedure will be performed until and unless in the last column we get the integers. Here you can see 3, 4, 8, 11, 12, 16, 19, 20. So these are the complete integers. So here we will finish our process by clicking on the calculate final value. Okay, so and we will perform up to that when we get all the or the maximum integers. After that, this software will automatically assign h square plus k square plus l square. On the value of this h square plus k square plus l square, we will have HKL combinations. So these combinations uniquely get the software from the database and will assign accordingly. Then we will have the lattice parameter, and finally you will find that the final result is FCC and the lattice parameter. So this tool easily calculate or the perform the experimental procedure. Here we can get the certificate of participation and then the complete data as well. So this is a complete procedure how we can index any unknown crystal structure with the help of mathematical method. So with this help you can find any of the crystal structure which is cubic in nature, be it FCC, body centered, or simple cubic or primitive unit cell. So you can perform this, and we have tested it with n number of samples and we find that it works very well. Now moving further, after doing the exercise, we have also provided various references, books of references. Therein you will find more about these calculations or these methods, or about the X-ray diffraction pattern, how to perform X-ray diffraction pattern and their analysis in these references. At the end you will have self-assessment. We have provided 10 multiple choice objective questions, and all these objectives are based on this exercise itself. So if you choose the correct options and then later submit it, it will also provide which one is the correct and which one is the wrong. So this exercise will provide you the complete insight into the indexing of X-ray crystal structure. Further, you will also find that these objectives are basically indicating the logic behind the getting HKL values. So if it is FCC, what kind of HKL combinations will be possible? If it is BCC, what kind of HKL combinations will be possible? So these logics and their objective types, the multiple choice is given in this self-assessment. You can find if you have chosen the correct, it will be a green. If you have chosen the wrong answer, then it will be a cross. And after submitting it, you will get. And if you click on the back, so you will again come on the front page of the virtual lab. So that's it. Here all about the indexing of a cubic crystal X-ray diffraction pattern mathematical method. And next we will see the same indexing of a cubic crystal X-ray diffraction pattern by analytical method. That is another method which can also be used to determine the unknown crystal structure of cubic type. At the end, I would like to sincerely acknowledge our principal sir, Dr. Suresh T. Silawat, sir, for providing this opportunity. Dr. G.D. Gupta sir, head of the department and vice principal. Dr. R.C. Dixit sir, professor and administrative officer, and entire IQAC team for teaching us the question paper analysis and giving guidance and their guidance to create such interactive utility in LMS. Thank you all.